We now discuss the solution of the problem that appeared in the joint entrance examination main held on 24th June 2022 in the second shift, and the problem is from the section coordinate geometry, and the problem is on ellipse, which uses the concepts of maxima and minima. The given problem is: let the maximum area of the triangle that can be inscribed in the ellipse x square by a square plus y square by 4 is equal to 1, where a greater than 2, having one of its vertices at one end of the major axis of the ellipse and one of its sides parallel to y-axis, be 6 root 3. Then the eccentricity of the ellipse is, we are given four options. Option A, root 3 by 2. Option B, 1 by 2. Option C, 1 by root 2. Option D, root 3 by 4. We are given an ellipse x square by a square plus y square by 4 is equal to 1, where a greater than 2. And a triangle is inscribed in this ellipse in such a manner: one of its vertices of that triangle is at one end of the major axis, and one of its sides of that triangle which is inscribed in the ellipse is parallel to y-axis. And it is given the maximum area of such a triangle that is inscribed in this ellipse is given to be 6 under the square root of 3. Then we have to find the eccentricity of the given ellipse. We now discuss the solution of the problem in detail. We are given the ellipse x square by a square plus y square by 4 is equal to 1, where a greater than 2. The major axis of this ellipse is x-axis. Why? Because a is greater than 2, and for this the minor axis is the y-axis, and the semi-minor axis, that is b, is equal to 2 in this case. So a is greater than 2, which is equal to b. Therefore x-axis is the major axis of the ellipse. Now that is our x-axis, y-axis, the origin, that is the given ellipse. Now the triangle that is inscribed in this ellipse has one of its sides, one of its vertices, say C, is at the one end of the major axis of E. So major axis is this, at this. So C is here, and with coordinates a comma 0, obviously. So because x square by a square plus y square by 4 is equal to 1, therefore this C will have coordinates a comma 0. And further given, one of its sides, say AB, is parallel to y-axis. So AB is parallel to y-axis. So AB is parallel to y-axis, and A is here and B is here. The coordinates of A, which you can take it as a cos theta comma 2 sin theta. Why? Any point on x square by a square plus y square by b square is equal to 1 can be taken as a cos theta plus a cos theta comma b sin theta. In our case b is 2, therefore the coordinates of a can be taken as a cos theta comma 2 sin theta. That of the b will be a cos theta minus 2 sin theta because it is in the fourth quadrant. So this is the coordinates of A and B, what we have taken, and the triangle is this one. So the area of such a triangle we have to find. So delta, let delta be the area of that triangle, that is 1 by 2 into the base AB into the height CD. CD is this. And that will be equal to 1 by 2 into AB into CD is CO, that is A, minus OD. OD is a cos theta. OD is A cos theta. So that will be 1 by 2 into AB. AB is AB is 2 sin theta and minus 2 sin theta. The difference. So that will be 2 sin theta minus of minus 2 sin theta. That is 4 sin theta into CO is A, OD is A cos theta. And now cancellation takes place in A. This A is common here. You will get 2A sin theta into 1 minus cos theta. Good. Now takes 2 sin theta inside the bracket. That will be equal to A times 2 sin theta minus 2 sin theta cos theta, that is sin 2 theta. So delta, the area of that triangle, is equal to A times 2 sin theta minus sin 2 theta. And we continue in the next slide. So we have that area we have already calculated. And now to talk about the maximum area, we have to take the first derivative of the delta with respect to theta equated to 0 and get the values of theta and use the second derivative test. So d delta by d theta is equal to A times derivative of 2 sin theta is 2 cos theta minus the derivative of sin 2 theta with respect to theta is 2 cos 2 theta. And it to be equated to 0. So d delta by d theta is equal to 0 will imply cos theta minus cos 2 theta is equal to 0 because 2a is common and that's constant. For cos 2 theta, we have written 2 cos square theta minus 1 in brackets, and simplifying we get a quadratic in cos theta, that is 2 cos square theta minus cos theta minus 1 is equal to 0, and factorization is very easy. The factors are 2 cos theta plus 1 multiplied by cos theta minus 1 is equal to 0, and this will give rise to cos theta is equal to minus 1 by 2 and cos theta is equal to 1. When cos theta is minus 1 by 2, theta is 90 plus 30, that is 2 pi by 3, and cos theta is 1 means theta is equal to 0. We take theta is equal to 2 pi by 3 and we reject theta is equal to 0. Why? If theta is equal to 0, go to delta and see a into 2 sine 0, 0 sine 2 times 0 sine 0. So this is the area becomes 0 and it is meaningless. So therefore we reject theta is equal to 0. So theta is equal to 2 pi by 3 we have taken, and we go to the second derivative and see what happens to the second derivative when theta is equal to 2 pi by 3. Let's see. So let us take the second derivative. Second derivative, that is equal to A times derivative of 2 cos theta is minus 2 sin theta, and the derivative of minus 2 cos 2 theta is plus 4 sin 2 theta. And what happens? The second derivative when theta is equal to 2 pi by 3, then substitute here A times minus 2 times sine 2 pi by 3 plus 4 times sine 2 into 2 pi by 3, that is 4 pi by 3. The values are minus 2 into sine of 2 pi by 3 is root 3 by 2, and sine of 4 pi by 3 is minus root 3 by 2, 4 times of it. 4 times of it. So that is on the whole it is negative. So the second derivative test says that the delta will be maximum when theta is equal to 2 pi by 3. This implies delta is maximum when theta is equal to 2 pi by 3, and the maximum value of delta is take the delta value and take the delta and substitute theta is equal to 2 pi by 3 in this. So we have substituted, and this is A into 2 sine 2 pi by 3 is root 3 by 2 as we have seen earlier, minus sine 4 pi by 3 is minus root 3 by 2, that is plus root 3 by 2. So on simplification we will get 3 root 3 by 2a, and what it is given, what it is, yeah, we continue, but it is given to us that the maximum area is 6 root 3, agreed. Therefore delta max is equal to 3 root 3 by 2a is equal to 6 root 3, That is 3 root 3, a is equal to 12 root 3, a is equal to 12 root 3 by 6 root 3, that is a is equal to 4. We have b is equal to 2, which we have already seen in the beginning itself, and we have a formula b square is equal to a square into 1 minus e square, in which a is 4, b is 2. So substitute these values and we get 4 is equal to 16 into 1 minus e square. Then 1 minus e square will be equal to 4 by 16, that is 1 by 4. That will imply e square is equal to 3 by 4. Therefore, e is equal to plus or minus root 3 by 2. Therefore, e is equal to root 3 by 2. And the eccentricity cannot be negative. Therefore, e is equal to root 3 by 2. So that's our answer for the question. That is, what is the eccentricity of the ellipse? The answer is e is equal to root 3 by 2. Our answer e is equal to root 3 by 2 appears against option A. Therefore, our answer to this question is option A. And that is an easy, simple question from the coordinate geometry. And the problem is on ellipse, which uses the concepts of maxima minima. I'm sure that you have understood the solution of this problem. I wish you all the best. Thank you.